Okay, so let's get started. We're going to be taking a look at working with our variable cam control tuning in this training module, doing a demonstration of setting up the proportional, integral, and derivative gains as well as our feed-forward value, and then putting reasonable variable cam targets within our target table, and then demonstrating using a mainline chassis dyno. We're going to be flipping back and forth between the mainline dyno screen, doing some wide open throttle pulls, and then just seeing how the variable cam timing is going to be affecting our airflow and our fuel model. It's very important to understand this relationship and also understanding how to complete a cam composite blend. Now we're going to be taking a look utilizing my Honda EP3 Civic. It's swapped with a Honda K24 engine, and we're going to be doing this calibration process for the variable cam on the low cam or non-VTEC. So right now we're going to just make sure VTEC's not engaged, and we're going to go through this simple setup and configuration. It's actually not that difficult, but there are a lot of things to keep in mind with this. I'm gonna try to break this down and make this as simple as possible so you can understand exactly what to do within the variable cam tuning process. Now, if you don't have a Honda engine, so you're working with, let's say, a Subaru with AVCS or a Mitsubishi, let's say an Evo with the Motec, the idea of the variable cam control is the same, meaning the setup, the PID configuration is going to be pretty much the same process we're going to cover here. And then going through and calibrating it also is going to be the same process. Now, we're utilizing the mainline chassis dyno to have everything in a controlled environment. You'll find that you don't necessarily have to have a mainline dyno to take a look at this calibration process, but utilizing a dyno is going to make things much easier. We will be talking about what you can look for if you don't have a chassis dyno as you're doing road tuning when you're trying to dial in the variable cam, what things we need to keep in mind. Let's jump in here and take a look. There's a lot of stuff to go through in this training module. So I'm going to move from my fuel tuning page, and we're going to jump across over here into our inlet cam VVT. My Honda K24 engine only has variable cam control on the intake cam. Now let's go in through the setup here so we can talk about a few things. So going down through here, we find our Bank 1 position resource. So that's going to be where I have my dedicated cam sensor, the intake cam tracking. It's going to be the universal digital input 3. And then the output, which is controlling the VTC solenoid, is controlled in a low side output. We can see low side injector 3 is utilized here. So I've wired one wire of the solenoid to a 12-volt power source. The other wire is then pulse width modulated, controlled from the Motec. We can see the calibration is set up in a manual because we don't have anything under the drop down to be able to select any of these options are going to apply to my Honda K24 engine. Now the position right here, we see an offset and a smooth. We're going to determine that as soon as we fire up the engine to get a feel for what these values need to be at. We can see here on the pin, this is going to be taking a look at the position resource. So we have pull-up control on, falling edge for the active edge. This is how the cam signal is going to be processed. It's a Hall effect square wave signal, so we can see we've set it here. The threshold is going to be 2 volts, 0 to 5 volt pulse, 2 volts, pretty typical. The hysteresis all set to 0.5 volts, and then the debounce here at 20 microseconds. That should work fairly well. Now, taking a look here under the control deadband, I usually start off with a value here of about 0.5 degrees, and that's going to say if the variable cam control is within the target, so within 0.5 degrees of the target we're programming, the PID gains won't kick in and make any kind of movement in the duty cycle adjustment to the control solenoid to get the cam advanced move to the target. So this is pretty good in terms of a deadband. I wouldn't go more than a degree, but 0.5 is sufficient. Just make sure if I have any little oscillations, the closed loop's not going to chase that and create rippling or oscillation effect based on the cam position potentially having some movement in it. So 0.5 is fine. Now the actuator here, this is what we're controlling on our low side injector output 3. It is going to be a low side output. Our reference volts should be 14. The polarity should be inverting when we're talking about advancing with inlet cam control, which is typically what we find on most engines. Minimum maximum duty cycle range of control 0 to 100% is fine, and the frequency we're going to control it at 300 hertz. So all these values should be sufficient to be able to control the VTC solenoid and also to be able to interpret the cam position sensor coming on our intake cam from the variable cam control. So we've went through some of the setup details here. Let's talk about our inlet cam target table. Now this table is set up here based on inlet manifold pressure and engine speed. My engine will be revving to about 8,500 RPM, and I've scaled my breakpoints here up to 8,000. This will be sufficient in terms of representing the engine RPM within the table. By 7,500, whatever our variable cam target is going to be by this point will be what we run throughout the rest of the RPM. So if we, let's say we're revving out to 85, 9,000 RPM, we'll be running essentially this variable cam target out to that very high RPM. We're going to find that the variable cam target really doesn't need to be changed once we get up to very high engine speed. So I haven't scaled it past 8,000. Now looking here at our inlet manifold pressure, this is going between 0 and 100 kPa. In this case, we're naturally aspirated engine, we're not turbocharged, so I don't need to worry about scaling anything past 100 kPa or atmospheric pressure. So we find the table has been zeroed out, and that's on purpose because I want to have the table essentially as a clean slate when we begin this process. The first thing we need to do here is sort out our PID gains. So we can see here proportional, integral, derivative gains. We also need to figure out what this feed forward value should be. I always recommend to start off with a feed forward value of about 40%. That works well for most VVT controlled engines as a starting point. This is the starting point in duty cycle control before the closed loop will kick in and adjust our value and the feed forward percent here to whatever the value needs to be at, so that the variable cam control solenoid can control the oil flow into the cam gear and allow that cam to rotate to the desired target that we program here. So 40% is fine, 0 to 100% is our range. We're gonna start off with a value of 40.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.